Hi folks, I'm going to get started like I always do by using the broom icon to sweep up everything in my environment, going to File, Close All to close my windows, and clearing out my console so that I've got nothing distracting me. And then I'm going to go back to the project folder, find the pre-labs folder, and then I'm looking for Inference 2-sample pre-lab because that's what we're talking about today. And maybe I'll make it a little bit bigger so it's easier to see. Let's see. I'll switch on that visual editor so that it looks nicer. I'll close that outline, maybe make this kind of full screen. So now we're ready to go. So we're going to start how we always start with the Mosaic package, and then we're going to read in the example data set I have for the class. As with last week, I think that my file path is a little wrong. So I'm going to take the read CSV parentheses, delete the stuff that's in the middle, and put in quotation marks. And then I can hit tab to get to that data folder and hit tab again. Oh, and there's only one data set in my pre-labs data folder. So then it suggests that for me. So this is the correct path. And then I can click play. So now I've got my same GSS data set that I use every week. And then I'm going to do just a tiny bit of data cleaning. It's possible that you'd need to do something like this for your final project, but I can help you figure out the data cleaning steps that you might need to do. So I'm not expecting that you would know how to do these sorts of things on your own, but it's pretty simple what I'm doing this week. I'm just going to filter the GSS data so that it does not have rows where these three questions don't have answers, where they're just sort of blank. So there's a question about should marijuana be made legal, there's a question about are you self-employed or do you work for someone else, and then there's that question about the highest year of school someone completed. Right now I've got 2,348 observations, but if I hit that play button, now I'm down to 1,392. So that's a smaller data set now. And then what we're doing this week is inference for 2 samples. That basically means we have 2 variables. Either we have 2 categorical variables or we have 1 categorical variable and 1 quantitative variable. And that turns into doing inference on 2 proportions or doing inference on 2 means. So like last time, we're going to be using a distributional approximation, so either the normal distribution or the t-distribution. And then our main inferential task for right now is just making a confidence interval. So we're going to start off with a difference of proportions. That's when we have 2 categorical variables, and we're going to approximate using a normal distribution. So if we were going to make our confidence interval by hand, one thing that we would need is the standard error. And that formula would be different if we were doing a hypothesis test, but right now we're just doing confidence intervals. So here's the formula. It's the square root of p1 hat times 1 minus p1 hat over n1 plus p2 hat times 1 minus p2 hat all over n2. So we're just bringing in the fact that there's 2 proportions. And then if we're using this distributional approximation, we need to check a bunch of conditions. And what those conditions are is n1 times p1 greater or equal to 10, n1 times 1 minus p1 greater than or equal to 10, n2 p2 greater than or equal to 10, and n2 1 minus p2 greater than or equal to 10. So basically we need all our counts to be over 10. So let's try it out. I want to do a confidence interval of the difference in proportion of people who said that marijuana should be made legal based on whether the person is self-employed or they work for someone else. So we could use R as a calculator and do that square root and those fractions and all that stuff, but we're going to focus on using the R functions because we're working with R. So the first thing that we need to do is find our observed statistic. And because we're working with a categorical variable, the observed statistic is going to be a proportion, and we're going to use the tally function. So I'm going to do tally, should marijuana be made legal, tilde, self-emp, or works for somebody, comma, data equal GSS, because that's my data set, and then I've thrown in format equal proportion. So if I hit the play button, it's going to show me this table. And let's just make sure that I have my variables in the right order. I'm pretty sure I do because this is kind of my response variable and this is kind of my explanatory variable, but it's easier for me to think about if I add up the proportions. So let's see, I've got this column for self-employed. About 69% of people say it should be legal. About 31% say it should be not legal. That adds up to 100%. And I think this column adds up to 100% as well. So of the people who are self-employed, 31% say marijuana should be not legal, and 69% say it should be legal, and the same thing for someone else, working for someone else. So let's see, what did I say we were going to do? The proportion of people who said marijuana should be made legal. So our observed statistic is basically the proportion of people who are self-employed who said that it should be made legal, minus the proportion of people who work for someone else that say it should be made legal. And I could hit the play button and it'll tell me that's the difference in proportion is 0.0429. So when we do inference, we want to know, okay, we observed a difference in proportion, but is that difference in proportion really, something to be interested in or not? And the other thing we need to do before we move on is make sure that the conditions for inference are met. And if you wanted to, you could do a bunch of multiplication, but the easiest way to figure this out is actually just to take off that format equal proportion and run this with just the numbers. Click and run the chunk. Okay, so I've got 98 people, 44 people, 809, 441. So all of those numbers are greater than 10, so I think I'm good to do inference. And I'm going to Control Z just to put back that format equal proportion because I want to think about those proportions. But yeah, the conditions, yes, the conditions are met. All the counts are over 10. Great. So that's our observed statistic. And then we want to make a confidence interval. So I have some code here. I'm using the prop.test function, just like last week, but now instead of just having tilde and then a single variable, I'm going to have a y variable, tilde, an x variable. And I'm just going to put in the variables the same way I did for the tally. So I made sure that they were correct in the tally, and now I know the way to do them down here in the prop.test. Then I can specify, my data. I have my conf level, and then I have put in success equal legal to make sure that it is picking the legal proportion versus the not legal proportion. And see if you can guess what I would need to change about this code to make this create a 90% confidence interval for me. So hopefully you guessed that I would need to change that 0.95 to 0.90. Yep. That's all I need to do, and then I can hit play. And let's see. It says it's a 2-sample test for equality of proportions. It found my sample estimates for proportion 1 and proportion 2. That's good. Those look like the numbers from my tally. And then I've got this 90% confidence interval. So how do we interpret that interval? I think it's going to be, we are 90% confident that the difference in proportion of people who believe marijuana should be made legal between those who are self-employed and those who are not is between negative 0.03, maybe I'll round, and 0.11. So because this interval contains 0, that means we're not very confident about there being a difference in these two proportions. So let's think about it. The way that we did our subtraction was prop 1 minus prop 2, right? That's what we did. Yep, and we had a positive difference. So that meant that more people who were self-employed than people who work for someone else thought it should be made legal. So if the whole interval was positive, that would mean that we were pretty confident that more self-employed people thought it should be made legal. And if our whole interval was negative, that would mean that we were pretty confident that more people who work for someone else thought it should be made legal. But because our interval goes from negative to positive, that means we don't really know what's going on.